There are various methods to solve these linear equations, but then the best method is I'm going to tell you now. So we are going to follow this method in order to solve all the examples. So I'll just list out the method and later I'll take examples and then work them on using this one. So I'll just read it out for you. See, working rule to find the solutions of the equation ax equal to 0. So this is the working rule I'm going to follow. First point is reduce the quotient matrix A to echelon form by applying row transformations only. Generally, in order to reduce the matrix to the echelon form, we are applying both the row and column transformations, right? But here, just use row transformations. See, we can use even column transformations, but it's going to complicate a lot of things later. So instead of dealing with all this complexity, we just will not apply column operations. We just apply row operations. See, the main reason why we are applying row operations is, I hope you know what this quotient matrix is. See, if you have 3x plus 4y equal to 0 and maybe 5x plus 6y equal to 0, then by applying row operations, what we are effectively doing is we are manipulating the rows, right? If you apply column transformations, you will be changing these numbers, and then this is not allowed, right? You cannot take 3 and then subtract it from 4. You cannot take 5 and subtract it from 6. It will just be helpful for you to find out the rank, but after finding out the rank, I want to even use the resulting form for the further processing. That is why I'll be careful that I'll not use column transformations. See, I don't know whether you got the reason or not. I'll just explain it again. Try to focus on this. What I'm trying to say is, echelon form is generally useful to find out the rank of the matrix, and in order to get to the echelon form, you can apply row and column transformations. That is fine. Which means using echelon form, if your intention is to find out only the rank of the matrix, you can apply both the row and column transformations. But then in this case, after getting the echelon form, I'll be using this form in order to do further processing. So for that reason, I don't want to change the columns. If I change the columns, the equations are actually changed. But as long as you are doing something on the entire row, it is okay, because the equations, if you change them from one form to other form using the normal transformation, that is fine. That is the reason. Okay, so just keep this in mind that we are going to apply only row transformations. We are not going to apply column transformations in this. And the next point is, if rank equal to r. So what does it mean? What is rank? So if you are applying only row transformations and if you got rank as r, then definitely if the total number of rows are m, right, then some of the rows m minus r, they become zeros, isn't it? If rank equal to r, so what is rank in echelon form? In echelon form, rank is nothing but the number of non-zero rows, which means the number of non-zero rows happen to be r. Then what about the remaining rows? They become 0. How many rows will be there totally? M. So if r are the non-zero rows, then how many zero rows will be there? M minus r. See this, if rank equal to r, then it means that in this process of transformations, m minus r equations were eliminated, which means all the remaining equations have become zeros. Then what does it mean? The given set of m equations are now replaced by an equivalent set of r equations, which means even though they have given us m equations, now we are able to eliminate some of the equations because those equations were actually linearly dependent on some other. So whatever equations we get, they are called linearly independent equations, which means they have given us some set of equations, but out of them some set is redundant. For example, see this, if you are given this set, and if you are given 6x plus 8y equal to 0. Now if you observe this, this one and this one, both are not required. One can be eliminated. That is what I am trying to say. So if we can eliminate one of them using the other, then we get the linearly independent equations. The other one is linearly dependent. Therefore, by using the echelon form, by applying only row transformations, whatever result we get, the final result, that will give us the number of linearly independent equations in the given equations, which means it is ultimately giving us the useful equations. Okay, I'm trying to explain this. If you can understand it, it is fine, otherwise don't worry about it. Once you see the examples, the method will automatically get induced in your brain. Okay, so now what I mean to say is we have r useful equations, we don't have more than that. Now when you have r equations, then how many variables can you solve? Only r variables. Therefore we can solve or find out r variable values, or we can find out the r variables in terms of the remaining variables. See this. Now solving these r equations we can express the values of some r unknowns in terms of the remaining n minus r unknowns. So since we have now, even though they said that they have given us m equations, we found out that there are only r equations which are useful for us, and all the others are just expressed or expressions of these r equations in some other form. Then what can we do? Using these r equations we can solve r variables. How can we solve them? We cannot solve them directly with a value, we can solve them in terms of the remaining variables. How many variables are remaining? N minus r variables, isn't it? Total number of variables are n, remember? Therefore the remaining variables are n minus r. Okay, so now all this happens under those cases only. What are the three cases? This r is less than n, r equal to n, like that. Now if these n minus r unknowns, so we are going to solve r unknowns in terms of n minus r unknowns. How can we solve them? The n minus r unknowns can be given an arbitrary chosen values. So which variables are going to be these known unknowns? See, which variables are going to be the unknowns for which we are going to solve, and which variables are going to take arbitrary values? I'll explain it with examples. There is no fixed rule, I'll explain that. Okay, and now this one is, these two rules you already know them. If r is less than r equal to n, then what does it mean? So we got from the set of m elements, we are able to get r equations. From the set of m equations we are able to get r equations, but then these are linear equations. So in this homogeneous linear equations we will not be able to solve this. So the only solution will be 0. Only under the condition that r is less than n we will be able to solve the equations. At least we will be able to solve for r unknowns, and these r unknowns can be expressed in terms of the remaining unknowns, n minus r unknowns. That is why we can get infinite number of solutions. Okay, why infinite number of solutions? I'll show you all this. I'm not sure how much you understood the theory. That is why I know I'm not trying to explain this much. Even if I try to explain it even more also, you will not be able to understand it. So with examples all these points will be very clear. So I'll try to solve as many examples as possible now. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.